Hey, science guys, happy Monday. Hope you had a good weekend, ready to get back to things in science. Last week you were learning about forces and we'd previously learned about motion. We're going to get into the next unit here, but it's actually very closely related as we talk about energy. Now, energy is something we maybe think about with forces and pushing and pulling. It takes energy to make things move. And that's all going to kind of tie together with what we're going to get into this week and what we've covered in the past couple of weeks. Okay, so it's really neat stuff. Today's lesson or this week's lesson is just what is energy. We're going to talk in general about what energy is. And again, just like motion and forces, it kind of sounds like it's like, it's just like stuff around you. And it is. And that's kind of the nice thing about learning about these things is that we're learning about things that are all around us all the time. We use energy to go around and do the things we do all day. Um, Cars use energy, things that move around or have energy. We're going to talk about those things that are around us that we might not always think about. But if we stop and study them, it's like pretty cool because it's like, everywhere all the time. So this particular lesson, today we're going to talk about just the general terms for energy and types of energy. Tomorrow's video, we'll talk more about specific forms of energy. And some of those are ones we see here in our picture with the fireworks. Now, fireworks are super fun. We'll talk tomorrow in our video then on the pages for the book about specific kinds of energy. Like here, one thing we can see is the light that is given off by the fireworks. There's also heat involved too. Those can be hot. Things like fire, of course, is hot. That's a form of energy. So thermal energy or heat energy we'll talk a lot about. Light is a form of energy. When we see fireworks, we also hear the sound that the fireworks make. Sound is a form of energy. And all those things we'll talk about a little bit more specifically tomorrow. But in this picture where it says what kinds of energy are represented, there's a lot that we'll talk about. Okay, we'll look closely at some of those specific kinds coming up tomorrow. Today we're going to talk more just in general about what energy is and energy all around us. Okay, so I'm going to kind of go through these beginning pages just kind of quickly. And point out a couple things. Okay, so a couple key ideas here. Again, kind of easy, simple stuff. Just have to apply it to what we're learning about here. It says a soccer ball won't move unless something gives it energy. Energy changes the ball's motion. So we need energy to cause motion. Energy allows the forces to happen that cause the motion. So for example, the soccer ball would just sit there until the boy comes and kicks it. He uses forces to kick the ball and put it into motion. All of that requires energy. So again, it's all kind of tying together. Okay. Here, a couple simple definition. Energy is the ability to cause changes in matter. Energy is involved when matter moves or changes shape. Again, that's kind of our key definition and key ideas. Okay. It says energy can transform or change from one form to another. The boy is using energy to run. The energy came from the food that he ate. So we have energy that we get energy from our food, and then that allows us to move our muscles and do the things we have to do. So it's kind of changing forms in that way, which again, we'll talk about that idea a little more moving forward. Okay. This part up here with the ice cream, we certainly know that ice cream melts, and when ice cream melts, it warms up and becomes warmer, and then it kind of gets yucky and slimy. They talk about how the particles in the ice cream are moving faster. Now I'm going to save that for what we'll talk about next week with thermal energy or heat energy. Okay, but basically what we'll talk about is that heat, how hot something is really a measurement of how fast the particles are moving in that object. So if we think of water, for example, liquid water that just kind of moves around pretty easily is moving around at a certain speed, if we want to think of it that way. And then when we freeze it, we have less energy in it. The heat is less. And really what's happening there is those particles that make up the water, little tiny bits of water, stop moving as quickly. And that's why they stay solid and they don't really move. Water can move around and flow easily when it's warmer, but when it gets really cold, it really means the particles move less, which again, I know that's kind of like a weird idea. It's something we'll talk about a lot more next week, but basically that's an idea that basically I think for now, heat is a form of energy. Thermal energy is a measurement of movement. Again, that's an odd concept when you're first hearing about it, but again, we'll talk about it more a little bit next week. Okay. What I do want to focus on with this page is what we see at the bottom, this true false section. A couple key areas here. Okay. So we're going to fill in T or F for true or false for these. Let's just kind of go through some statements here. Just a little smaller. And we can talk about is this true or false for each. Okay. So our first statement is energy can cause changes in matter. That's definitely a big true one. Okay, I'm going to put a big capital T for true. Energy can cause changes in matter. It definitely does. That is something that we're talking about quite a bit. We need, for changes in matter, it could mean it moves or it changes shape. We need energy to be able to do that. Okay. How about energy can change from one form to another? That also is true. Okay, we'll talk about how we can go from, and we'll see on our next page, what's called potential to kinetic energy. We can also change from electrical energy to light energy when you turn on a light bulb and things like that. Those are the things we'll talk about more specifically tomorrow. But for now, just know we can change forms of energy. The one that's false is number 3, which says energy can be used up and destroyed. That is false. We can use energy, like we use energy when we, like I said, run around and do the things with our bodies, or our cars might use energy when they use gas to make them go. But that energy doesn't go away. It just changes form. So this number 2 statement is the important one. And again, number 3, this idea that energy could be used up or destroyed, it's actually false. It changes form, but it doesn't actually go away, which again, that might sound weird because it's like when I ate my food and then I get hungry, I used up that energy, right? In a way, yeah, you use the energy, but you actually change the form of it. And again, we'll talk more specifically about that in the next couple of days. Our last one, energy can be transferred from one object to another. That's definitely a true statement. And a quick and easy example is what we see on our soccer ball here, right? If we transfer from one object to another, we can take the energy in the kid running, and he kicks the ball with his foot, and the energy goes into the ball and makes the ball move down the field or whatever it might be. Okay, so that's one where it is a little bit easier to understand that energy can be transferred from one object to another. If you take the energy in your hand and throw a baseball, that energy is in the ball and it's moving because of the energy. It's changing. It's moving where it is, changing its position. That is an example of how we can also transfer energy from one object to another. That's an easy one to get. Okay, so some of these we'll talk about more specifically. We're just kind of going over them quickly now. What we have on the next pages for today are these ideas of potential and kinetic energy, and there are a couple of good examples here of that. Basically is this: potential energy is like the energy that could happen. It's stored energy. It could cause an object to move, but maybe it's not moving at the time. Okay, so it says here the energy an object has because of its position or condition is called potential energy. One way that potential energy can really exist is when we think about gravity. If you're that kid at top of the hill, or top of the sled hill, you have potential energy because gravity is pushing down, and you could go down that hill, but you might be sitting still at the top of that hill, much like at the top of the roller coaster hill. Okay, we'll look at this roller coaster a little more closely in a second. The energy we're going to most often think about, is the easiest to understand, is the energy of motion. The energy an object has because of its motion is called kinetic energy. So kinetic means moving. Potential means it could move. It has the potential. It's possible that it could move, but maybe it isn't right now. Kinetic energy is basically energy that's in motion. Now, sometimes that might mean actual moving objects. Sometimes that might mean things like this example of the match over here, burning and kinetic, moving in that way. It's using, the energy is being used. Okay, sometimes energy is stored, and that's called potential energy. Sometimes energy is used, and that's called kinetic energy. Okay, so if we first look at the roller coaster example, I'm going to zoom in again. The roller coaster, we're going to label where there's potential or kinetic energy. It says when the roller coaster is at the top of a hill, most of its energy is potential energy due to its position. Gravity will change the potential energy to kinetic energy as the car starts down the hill. So when it's at the top of the hill, if you've ever been on a roller coaster, you maybe stop for that split second. You're like nervous. Oh, I'm about to go down. It's going to be fast. When you're paused for that moment, that potential energy is there because you could move, because the gravity is what pulls the train car, the roller coaster car down. And that's where we have potential energy. So here at the top, I'm going to go ahead and put PE for potential energy due to the position of the roller coaster cars. When you're at the top, you have more potential energy because you're higher up from gravity, and gravity has more ability to pull down. Okay, so that's an example where we have potential energy happening here. Then if we go to another section, what do we have? It says as the car moves downhill, its potential energy changes to kinetic or moving energy. So kinetic means moving. Usually, again, things in motion have kinetic energy. At that bottom of the hill, the car's energy is kinetic. this KE becomes PE, kinetic becomes potential, as the roller coaster car travels up the next hill. Okay, so here at the bottom, when you're going really fast, I'm gonna go ahead and fill in KE for kinetic energy. You kind of reach the bottom, you're going the fastest you can because gravity is taking you down, 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 down as you pick up speed due to gravity, and that's an example again of kinetic energy. Okay. Now here, I think we're kind of looking more up at like being up at the top again, or maybe starting down. I'm going to label that as potential energy. And we're up at the top of the hill. We maybe not go down yet, but we have that potential to go down, which means it could be potential energy. Okay. Let's go back now. A couple more examples of potential and kinetic energy. Sorry, I'm going to zoom around all over the place here. It doesn't have to be just cars or trains moving around or things like that. We can have potential energy in like a spring. Now, if the spring is just sitting on a table, it may not have potential energy or kinetic energy. But if we kind of squeeze down the spring, we cause what's called tension. And that tension means it could be released. And when we let that spring go, it's moving. That's kinetic energy. But when we apply tension to it and press it down, that's potential energy due to the tension that's there. There's stored energy in there because as soon as we let go, it flies off, and that's when it's kinetic energy, when it's moving. Okay, so that's one that's easy to kind of understand. Kind of related to gravity with the roller coaster. Now, one that's a little more difficult is this one of talking about the match. So the match has potential energy, like just like wood on a fire. If you have a wood pile and you've done a fire pit, I know like last couple of weekends or couple of days, there have been warmer days or evenings where you might have roasted marshmallows. I got to do that, which was super fun. There's stored energy in that wood, just like there's stored energy in gasoline or charcoal. If you grill for, making fire, the fireworks could have the stored energy. Potential energy can also be stored energy in the form of like this match that's got the chemicals in the match head, and when you light it and it allows it to burn, when it does burn, that becomes kinetic energy. Like it's actually using that energy to create heat or light or whatever it might be. Here we have a match that's not actually doing anything, but it has the potential. It's flammable. It could become burning and giving off light and heat, which are forms of energy. But in this case, when it's just here like this, it's just potential energy. It could become kinetic energy, but when it's just sitting there, it's like stored energy. Just again, like a car with a gas tank full of gas, it might be sitting there not using it, but it could go. Okay, so that's that idea here. Again, potential means possible or it could be moving, and kinetic is when it is moving. Now you may not think of a match burning as a moving thing. It's not moving like a car moves, but it's using the energy. It's burning, it's giving off heat, it's giving off light. It's taking that stored energy in the wood. Again, you can think of the matchstick or a log on a fire, and that energy stored in there, when it burns up, it gives off the energy, and then that's like a form of kinetic energy. Okay, so that's kind of what I mostly wanted to cover today, just to introduce. What we'll get into tomorrow is some things to do with specific kinds of energy. Like I've mentioned, heat and light, and those are kinds of energy. We'll talk about some other ones as well. Okay, so today mostly just talking about like what is energy, a couple of things about energy, types of energy, potential and kinetic, and then we can take those ideas of potential or possible energy or stored energy, and then also talk about kinetic or moving energy as we talk in our next couple pages of the lesson, which we'll watch tomorrow, which we'll get into specific kinds like electrical energy, thermal energy or heat energy, light, sound, all those things. We're going to talk about all kinds of neat stuff, okay? All those things around us. Again, that's what's fun about these lessons. I know science can be fun a lot of times. We've learned about space. We've learned about ecosystems. Now we're learning about the things around us, and that can be pretty cool too. So hope you enjoyed this. Hopefully this was helpful to help you kind of go along with the reading you've done. Tomorrow we'll cover the next couple pages, and we'll go on from there. All right, so enjoy the rest of your Monday, and I'll talk to you with some more science on the next one. Thanks, guys.